So this was a pop quiz which was related to time period, motion, Hooke's law, and mass, weight, and density concept. In the first question, a student investigates a pendulum. He measures the time for the pendulum to complete 20 oscillations. He repeats the experiment 3 more times and the readings are shown. What is the average period of pendulum? So first, this is the time for 20 oscillations. We have to find the time for first one oscillation and then we'll take an average. Or you can take average of these and then take a time for one oscillation. But so it is like 17.6 divided by 20, which is 0.88. That is the time for one oscillation. 19.8 divided by 20, 0.99. 17.6 divided by 20, 0.88, and 18.6 divided by 20, that is 0.93. So then we have to take an average. How to take an average? We add them and divide it by the total number. So 0.88 plus 0.99 plus 0.88 plus 0.93. And then the whole is divided by 4. So that's equal to 0.92. So B will be the right answer. The next question, a car joins a road at the speed of 14 meters per second. So that's the starting speed. Accelerate 4 meters per second square. So that is the acceleration of the car for 5 seconds. You need the final speed of the car. So how you can work out the final speed? You have the formula for acceleration. Acceleration is a change in velocity divided by time. So the acceleration is 4. The final speed, we don't know. The initial speed, that is 14. And the time interval is equals to 5. Now we simplified for B. 5 is divided, other side will be multiplied. So 4 multiplied by 5 makes 20. So 20 is B minus 14. This is minus 14, other side we will add. So it will be 20 plus 14 is equals to B. That will make 34. So D should be the right answer. Question 3. A metal wire is loaded up to limit of proportionality. What is the meaning of limit of proportionality? It means force and extension are directly proportional till this point, and we will have a straight line which is passing through the origin. So Hooke's law is not obeyed. That's wrong. When the load increase from 0 to this point, no, it obeys the Hooke's law. When a load increase beyond the limit of proportionality, the diameter of a wire will increase. That's wrong. The diameter of the wire will decrease. Like example, if you have a wire and you attach a load to this wire. So a load is attached to the wire. If you increase the load, what will happen is the wire will stretch. The thickness of the wire will decrease, not increase. So that's why the statement B is also incorrect. What about C? When a load is removed, the wire will return to its original length. That's right. Like within limit of proportionality or within the elastic limit, when we remove the force, the object will return back to the same original length. And why option D is not the right one? Up to limit of proportionality, there is no change in shape of the wire. That's wrong. Because when we increase the load, the wire will stretch and there will be a change in shape, like as the length is increasing. So there will be a change in shape. That's why D is incorrect. Why B is wrong? When load is increased beyond the limit of proportionality, the diameter of a wire will increase. No. When we stretch the object, when we add a load, the wire's diameter or the thickness of a wire won't increase. It will decrease. Because when you're stretching something, what will find you will find its area start to decrease and the length start to increase. So that's why it is wrong. It should be decrease, not increase. And why D is wrong? Because up to limit of proportionality, there is no change in shape. That is wrong because when you add a load, the wire will stretch. So whenever the object stretch, that is the change in shape, change in size. So it's changing the length means it is also changing the shape as well. When you apply, according to Hooke's law, increasing a force, the object will also stretch. So force and extension are directly proportional. Applying more force, the object will show a greater change in length. So if the length is changing, the shape will also change. Is it clear, this one? In question 4, a student carries out experiment to find the density of a rock. Two measurements are there. This is the mass of the cylinder plus liquid. This is a mass of a cylinder plus liquid plus the rock. He want to calculate the density of the rock. So to get the density of a rock, he need the mass and he need the volume. How to know the mass of the rock? Like how much, or what is the mass of the rock? How we'll identify? It was 200. The mass of a liquid and the measuring cylinder is 200. And mass of a liquid measuring cylinder rock is 264. So how much the mass has increased? So we need the increase in mass, which is 64 here. And to measure what volume, or because we need the density of a rock. To get the density of a rock, we need the mass of the rock and we need the volume of the rock. How to know the volume of the rock? If this volume is V1 and the other volume is V2, so how to know the volume? It will be V2 minus V1, the difference. So we have to take the difference of the mass and the difference in the volume or increase in volume to know the density of the rock. That's why A is the right answer. Is it clear? Question 4. In question 5, the gravitational field strength is 8.8 for Venus and 3.8 for Mars. An object has a weight of 42 newtons on Venus. What are the mass and the weights on what are the mass and the weight of the object on Mars? So we have the formula weight equals mass into gravity. So mass of the object on Venus is 42. Sorry, weight is 42 newtons. Mass we don't know. And what about the gravity of the Venus? The gravity of the Venus is 8.8. So this 8.8 is multiplied, other side it will be divided. So 42 divided by 8.8. 42 divided by 8.8, that's 4.8. So 4.8 kg. Because as we know, the mass of an object does not change, remain same. So if the mass on the Venus is 4.8, the mass on the Mars will also be 4.8. So the option which are 4.8 are the right one. Either A can be or B. Then what about the weight? Weight is mass multiplied by gravity. As the gravity of the Mars is different, the weight will also be different. Mass remains 4.8, but the gravity of the Mars is 3.8. So this will be 3.8. 4.8 multiplied by 3.8, that will give us 18. So means the weight on the Mars is 18 and the mass on the Mars is 4.8. So it matches with option A. So A is the right answer for this. So this was a pop quiz related to time period, motion, Hooke's law, mass, weight, and density concept.